Last week we looked at the built-in exceptions, so that how we can avoid uh, any uh, any uh, force any expected error uh, if that hold uh, our systems, but whether we want to run our systems continually without stopping uh, our programs. Um, so many exceptions, if they are expected, well, then defined by native Python environment. But as you may expect, there are lots of different cases that um, and each system has different business logics. Therefore, different rules needs to be applied, different policies, and all such policies and rules may not be covered seamlessly. If there is any loose point in your considerations of your system buildings, then that is the point that system may halt at some unexpected time point, or that may be the loose point that attackers may intrude your systems. So for security reasons, for safety reasons, the exception needs to be handled properly. Therefore, all the considerations should cover entire spectrum of the scenarios. Okay. So many of the exceptions and errors are already developed. Developed means the class of exceptions are defined. Many of those are also proper messages written. Therefore, we can simply display it, print it. It is true also all the error messages are not necessarily relevant to the errors that we encounter. There are many cases the error messages are not really precise enough for us to see what has been happening. So to cover some of the error, some of the exceptions that may not be already defined, or that may be specifically related to the problem domains that we are handling right now. For example, if you are involved in financial sector, fintech systems, then exceptions that may occur in fintech applications may not be considered in native Python exception families, right? So those things need to be handled by the field experts. So you guys all will be experts in cybersecurity, either operations or cybersecurity developments. Therefore, some exceptions need to be defined by you guys and also handled such things. So today we will look at that, how we can define exceptions, how we can raise that exceptions in our codings, therefore handled properly. Okay. So in Python, try to do that as it says. We do try, okay? If there's anything that, without try, if there is an error, then your system may halt, okay? It doesn't move. So try close in our language, that is literally try. So try, see if anything happens. If something happens, then we need to do some handles. So roughly, I want you to take a look at here. This is a while loop. So we continue to do this, not only one time, but we do until we fix the problems. If this is, for example, your system wants to receive the years of user experience, then you need to take it. Okay. So user may not carefully enter the number. Then you need to ask user to enter a number. Although your program has nothing to, there's no errors. You simply wants to convert. If user wants to, you already said enter years of your experience in integer, for example. But user may enter something else. But you want to convert it to integer. Then this, the first line of code, this one's input code, right here, you have an error. Your system stops there. If that is not what you want, if you want to anyway give full service to users so that your system needs to receive right user input. For example, in this case, years of experience is greater than 2 and less than 19, less than or equal to 19. For example, right? This number is ridiculous, but anyway, if this is the policy, then you can do something. User entered the integer number properly, and that number within this range, then your system will be happy and say you are qualified application with whatever that is, right? And then use your system complete, mission done. What that means is that experience error equals false, experience error here initially true, your while loop condition is on this express whatever exp error. As far as exp error true, this while loop continue to work with the customers. If this first condition is satisfied, then your mission is done successfully. Therefore, while loop is no longer needed. So we have exp error equals false. What that means is that while loop will end. User entered the integer, so that is a proper input, but not in this qualified number range, which is the else case here. Okay, this type of unusual condition may not be defined. Any exceptions like this may not be defined by Python, of course. So this kind of exceptions needs to be defined by us, right? For some specific unusual environment, application domain. So that exceptions needs to be defined somewhere. Let's say experience error, this is an exception. So we need to raise these exceptions. Although user enters the number for experience, and if that number is not some qualified number range, then we need to raise exception. And then we handle that exceptions. So we have a raise here, and we have except. As far as you have a try, colon, so everything here that is a try block, try code block. This try code block should be followed by except block. So try and except goes together. If you say try only, but no except, no, it's not. Some other language allows. For example, Swift for iPhone apps developments. Only we say try, but not try similar to other regular try, but we can say try question mark. Then, hey, I want to try this, no matter what. That is another story. But here, Python, try, once we have a try, then we need to have except. Raise in this case, this is a reserved word followed by one of the exceptions that we already defined or already provided. Then raise is nothing but instantiation of the class exception class. If you think you do not understand what I am saying, forget it, don't worry about it, okay? This is something who those understand the object-oriented programming, okay? So raise and this exceptions class and open and close parentheses. This is nothing but the object constructor by which an object can be instantiated. Again, this is very lots of jargons, terminologies involved in my explanations. But anyway, there we can enter some of the messages that we want to express, particularly from these logics. That'll come later. In the except block here, not necessarily from this exception itself, but we could do that, right? We will do that. This is not really properly. Instead, we simply print something that we want to say. This is something that we want to say may be entered into this constructor so that an object of exception can be instantiated in this else statements. And when it comes to except statements, we can bring it out. There are many ways. We have one example later in the lab. So when we do raise the exception class, then it goes to that exception class. So we'll do exception. So this is the way that we can define an exception. When we define an exception, then exception is a class, like this class. But it is not just class. Okay? What I mean by that is exception should be part of exception hierarchy. It should be in exception hierarchy. In our Google Colab, the hands-on lab, if you scroll down a little bit, then I included the hierarchies. This is a hierarchy of exceptions in our Python environment. In this hierarchy, on top, there is a class called the base exception. So all the exceptions somehow should be linked to this base exception, because this is a hierarchy. This is on top, all others bottom here. Okay. If we see this is a tree, then this is a root, and all others are leaves. Think about the trees, upside down trees. This is root, leaves, upside down. All of this, each of this is somehow related with this root exception. So we call that this on top. This is a superclass. Anything under that's a subclass. If this simply exception is a superclass, then under this every other that is also a subclass. Runtime error, this is a superclass, and then not implemented error, that is a subclass of runtime error, and the recursion error is a subclass of runtime error. In turn, runtime error is a subclass of exception, which is in turn a subclass of base exceptions. So they are like subclass and superclass relationships along that hierarchies. So when you define some exceptions, you can plug your exception under some of the exception called the error, or some of the exception generator exit, some of the key interrupt exceptions, system exit exceptions. Okay, this is an example for the exception cases here. So this error, this is my exception error. No, this is an exception already defined here, right? That is an error. So error is a subclass of exceptions. I think error is our error, maybe, or built in. So this is an error. Error is a subclass of exception. Then error should be here, not under this base exception. So in this case, you need to be error is a subclass of a base exception. If we match this with the collab here, this should be base exception. Then error is a subclass of base exception. As you can see here, error is a subclass of a base exception. Okay. And this is your simply comments. And then pass means you don't do anything. You just create error exception. There's no specific things that you want to add. No function is added. No field is added additionally. But there is a function already defined in this built-in. This is a built-in exception. For example, how you can initialize the exceptions with error messages. Okay, then you need to have a def init function. Def init function means like this. Error is my class, which is a subclass of a basic exception. There is a init function defined, and then it takes message m. That m is plugged into self.message. As you can see here, there is no messages field. How can we know this message is available? This is message is available by these base exceptions. Base exception itself has already message field that is inherited, because error is a subclass of base exception. everything, all the properties available in this superclass can be inherited by subclass. So without having to define, for example, this message, we have messages. To this message field, I want to assign the given message into my exception messages. STL, there's another the magic function. If we have STL, then this guy says only return self.messages. What it does is that when this error object is to be printed without having to say anything, then this function is automatically activated. What this function is, that function returns messages. We'll look at that. Okay, so this, other than that, we pass. That is exceptions, exception definition. So we define exceptions like this. Once we define exception error, based on my exception, this is user-defined exception, right? Based on my exception, I can also define further exceptions, which is experience error, and pass. Okay. So this is another reference. In Java, if you want to do exception handling, Java has the language try, catch, finally. What is the language in Python? We already looked at, right? In Python, try, except. Try, except, finally. In Java, try, catch, finally. Try some of the logic. If there is any errors, any exception takes place, then catch it. In the catch blocks, some of the handlings needs to be implemented. That's what we have here, right? And the catch block or except block, this is our handling. Our handling is nothing but explain the error messages. And then we re-ask the same question until we're satisfied. Therefore, we turn this while condition to false, like this. So we keep educating the users until user enters the right input. Along that way, a few of exceptions are raised and therefore handled. This is a Java case. Swift, this is for the next generations of Objective-C in iPhone apps developments. There we use do, try, catch, close. We need to do first. Hey, do it. And try and catch. So we don't do that much here. But simply in our logic, we say do. And then we have here try. So get input. In this input, we do something. If there is any error occurs, for example, years of experience is less than 3, then we throw this specific case. Along this logic, because that is an error, we don't take care of it, but at this point, we need to throw it. Then somewhere means in catch, close, this guy will catch it and handle it. Okay, so we have a throw here. If it throws, then because we have exceptions, definitions, so that can be handled. Okay. So we'll look at this. Let's look at it. This is an exceptions. So error is an exception in object orientation. That is nothing but a class. So class is a skeleton, like a blueprint of objects. There may be multiple errors to take place. Each of those errors is an object, right? But we need to have some blueprint about errors. So we define error as a class. This is a blueprint. So class error, which is a subclass of base exception. So initialize and then string, the one that we just looked at a few minutes ago in the code lab. Okay. And under this error, other subclass called too little experience, or others is too much experience. If you want to interview some applicant, for example, then we can create based upon the application's description, then we can find out some of the exception cases, and we put some error messages there, and as one specific exception is called the too little experience. There may be some applicants with the too little experience, or on the other hand, another extreme end, there may be some other applicant groups with the too much experience. We need to handle separately, right? And each one might have some of the messages. So reviewer look at application packages, and we can raise the exceptions with some messages. Then message comes here and generate an object of that specific errors. Okay. So when we do that, then we have here errors, and underneath we have too little exceptions, too much exceptions, right? In addition to exception A and exception B. So exception A and exception B. Before we get to that, we have, let's assume this is a hierarchy currently. Once we define this exception classes, after the definition of that exception classes, then our hierarchies becomes like this. This guy added to as a subclass of errors. Therefore, when your program runs, even if you say raise these messages and accept and exceptions with some objects and print that object, then even if I say print an object, if I say print an object, it doesn't make sense, right? Print an object. But because I said here, when I say print an object, then this guy says, hey, that's nothing but the message that I have. So this guy, boom, print that messages. As far as we have underscore stl underscore open self close parenthesis colon return self dot message. As far as we have this function defined with the exceptions that we have, then if we want to print an object itself, then rather than anything else, this message is printed. That is the concept of this is called the magic function, which can be defined in any class, not only exception class, but in your any classes in your codings, if you do it in object orientations. Like if you want to construct an object of a class, and if you say, hey, I want to construct an object with this kind of initial values. For example, I want to construct an object of students called James. So James object can be initialized with a name, age, major, GPA, so on and so forth. So the fields that can be initialized when an object is first constructed, then all of such things can be defined here. Underscore init, underscore self is nothing but object. So forget about that. Self comes like this, object dot something, followed by whatever the values. As I said, name, age, major, GPA, all those things needs to be defined, right? Okay. So once we have these exceptions defined, then we will have here while loop and try. While condition is except experience error. Experience error initially true, therefore we run this while loop. If experience whatever number is less than 2 years, then we say we raise too little experience. This is too little experience here, right? With the messages, this message is entered into the too little experience object dot message, because this whole thing is inherited here. Even if we don't declare this, these things is available here. These things also available here. Too little experience, too much experience, both have this kind of things. In addition to this, if base experience defined other than this, that also inherited. That also inherited here in the level of error. which can be also inherited. Too little experience, too much experience. So this guy's inherited too much, right? If your ancestors are rich, then you can inherit lots of properties. By the way, hopefully you guys all have wealthy ancestors. So I mean, therefore you might have wealthy inheritance. But personally speaking, I have zero inheritance. Why? Because my parents was poor. Why my parents was poor? Because their parents, my grandparents, all killed in Korean War by communists. Some were killed by North Koreans, some were killed by Chinese soldiers, some were killed by Russian soldiers. Rarely Russian soldiers, but mainly Chinese soldiers and North Korean soldiers. Anyway, there's an inheritance. Okay, so if you are descendant, I'm descendant also. So inherited. So you can use it. This too little experience, if you see this too little experience as is, there's no properties. But properties available from ancestors. So we can enjoy to use it. By sending these messages, too little experience, object can have the message. This is the message associated with an object of too little experience. Another case, else if experience, number of experience, years of experience is greater than 33. 33 years old work experience, then I think enough to retire, right? I guess. I'm not reaching this many, so that's why I'm still working hard. But this number is not my number. I do not know what number that I want to do. You guys do not know, right? You guys do not know yet what number of your work experience before you get retired. So in this case, the too much experience. Message, this is just dummy messages. So here we raise exception. When experience is less than 2, we raise the exception. This also raise the exception. Once it is raised, then handled. It can be handled here in this the exception class definition. Exception will be handled here. And based upon this definition, more precisely, handled here in except block. If you see this except block, then doesn't matter here. Automatically, this guy knows, hey, this is not just a class, but this is an exception class. Same thing here. You don't need to, all of this can be considered and handled. If that is too little experience, then the object raised here somewhere, we don't need to care at this level. Whatever that is raised, let's call it E, and we print E. E is nothing but an object of these exceptions. Print E, print an object. As I said, that is legal as far as we have underscore str underscore function defined with that exception. Same thing here, too much experience as E. This is an object of too much experience. That object is printed here. In our case here, exception handling simply display messages, right? But you can do more. This is except block for the case of too little experience. If you want to do more, then more statements here in this same indentations. Print, you can whatever you want to do, logics. Big, long coding list can be here, or within this, you can also invoke other function. That is also possible. This handling, in this simple examples, looks so simple, but it's not open, right? You can add more and more statements. So user-defined functions in this way. You have to first define, and then in your codings, try, raise, you have to raise, try and raise some cases, and then handle in the except block. Okay, so practice. So last week we looked at the built-in exception. Today, user-defined function, user-defined exception. Here, user-defined exceptions. Write a Python code to create a dictionary of employees. I keep changing this, right? What is it? Employees and monthly pay pairs. Monthly pay and amount pairs. Assuming the range of employees' monthly pay for each employee, a monthly pay is interactively received. So we want to create a dictionary. So that should be inserted into the dictionary. Only if a given salary is in the permitted range, the employee and salary pair can be stored in a dictionary. How it looks like, just not yet. How it looks like. It looks like this. So Chris has 2,500, Bob 5,000, Jensen 9,000 and things like that. So before we get to that, this is some blank. If you fill this blanks, then it should run like this very nicely. But before we get to that point, let's say we define this function, dictionary generator. This dictionary generator takes a dictionary key and value amount. And this dictionary can generate a this function can generate a dictionary if amount is in this range, 1,000 and 9,000. Then dictionary is generated. Other than that, you simply say error. And D can be either a dictionary or a string that is returned. Assuming this is a function. This is an unknown function. That function returns only something in our logic. Okay, so by reading this employees list, and initially this month pay is an empty dictionary. So for each employees, we can ask user enter the pay for each one of these employees for this month. Then that is called here month pay, and then we call dictgen function, which is this. We send dictionary, current dictionary, the previous dictionary, and then employee name and monthly pay. Then employee name and monthly pay. Employee name is a key, monthly pay that is amount that is entered. Therefore, we will eventually have this. Chris has 2,500. Okay. So if we run this, then say Chris, so we can say 7,000. Okay. So initially we have an empty dictionary. Now we have one element in that dictionary. Chris 7,000. And then Bob. I do not know. I can give you Bob $15 minimum salaries. Boom. Given dictionary is error, according to this. So if we give David, for example, $3,000, at this point we have an error, right? Because this is not a dictionary. We didn't check any exceptions in this logics. We have proper function. We call that function. This itself also, there's no error at all. But there's some exceptions takes place. How can we do that? To do so, we need to have try, raise, except clause. So we need to first create a exception class. Say pay range, that is exception class, which is a subclass of base exception. Okay. Also, it has underscore underscore init underscore underscore function that is available. That is a property defined in the top superclass. So pay range exception can inherit it. Same thing for stl. So we define that. So in order to run this code safely, right, without causing any system halt, how can we improve these things to here? So this for loop, so far here, no problem. Okay, same, we didn't change anything. Now we need to do try. If monthly is less than 1,000, then we raise. We can say raise the pay range, that is exceptions, pay range. And then because it has the message arguments, so we can say here too low wages. And then we have an else if, which means it is not lower than 1,000. So it is greater than 1,000, but less than 9,000. Then we can say, only in this case we invoke that. So we can say this month pay is nothing but all the way here dickgen, right? So we can say dickgen. This guy has this month pay and then employee and monthly pay. Only in this case we invoke this function, and this is too much, right? So that we can also raise pay range with the message. So in our logic, we do have a try with the raise. Therefore, we need to have, once we have a try, then we need to have except. In this except, we need to catch the exceptions, which is, no, exception is called the pay range. Pay range as E, because we already print E, so this object should be that. We can do more, print finally we print the final dictionary. So this guy should work if we properly run this. So that function is defined, and then this is exception is defined, and this is our logic. And therefore, if we have $5,000 for Chris and Bob, that's $0. We simply say too low wages. Still, we have Chris $5,000, right? It's not the case here. This is a dictionary, and another dictionary simply say errors, so that we have this kind of errors. But this is robust, right? Chris and Bob has a 0, still okay. We simply say too low wages. And then still the same dictionary is considered. And then David, let's say 799. 799, that is also too low. And Jason, maybe 8,900, that is taken well. So Chris and Jason. And then this is Jason and this is Jensen. Jensen, I would say 111,000. Too much over wages. So far, finally, we have a Chris 5,000 and Jensen 900. This is the pace that we need to prepare for our employees in this legal regulations. Any question about these exceptions? So I want you to practice this well by changing this and there. See how we can handle the exceptions. So our system will be robust, like this, but not like that. Not like this, but this. So it's multiple exceptions. And also nested exceptions possible. We can say try if this try paired with this except. And then another try here that is paired with this except. So if you see here, then this is only this try. Try. For some cases, you raise that exception and finally handle it. This is inner exception module. And outer, we have try and raise and accept. So let's take an example. We have two exceptions, EX1 and EX2. Both are based upon base exception. Initially, any key true, while any key means while true, right? So we will continue to do this. While we are doing this, we try. Ask user to enter any keystroke. Take it. And if that is in this, any one of these keys, okay? And another while loop here, and therefore we have an inner try. If that is a left key, enter any key. So enter any keystroke. If your key is any one of these, fine, accept it. And ask again, enter any keystroke. If that is A, S, D, F, G, then that is left side keys, right? Left hand, if you use two hands. Then you can say a key from the left fingers. If it is from the other, T, U, N, then key from right fingers. Anywhere in marginal center of that left keyboard and right keyboard, but there is in the middle, in between, somewhere in the boundaries. So each one may have different, sometimes you can use the right finger, some other guys may use the left finger. We do not know clearly what it is, right? So we can say you may use either finger. Okay, so let's just run this. So try anyone's. So if I type, for example, 7, then this guy say enter one key only. 7 is not here. If 7 is not here, then from here there, we don't do anything here, but else. Raise EX2, enter one key. That exception listed here. And this keep doing that. This enter key is to be false only if we do this. If any one of this, then here. See here, enter key becomes false. So let's say if I type H. H is not here, right? So let's say F. F, then F, okay. So this passed. So we are now inside this. Yeah. So let's assume there is a left key, otherwise a right key. So enter any keys. So if I say S, if I type S, then that satisfies this if statements and print that. And at the end, there's no exception is raised. Therefore, this any key will left key will be false. Yeah, if it is a left key, left key is false. Keys from your left finger. Enter any keystroke. So if I say what it is, for example, N, then that is done. Therefore, in this case, this is only the case If any one of this, if you type any one of this, then we stop and finally say bye. Otherwise, this go further and further. So if you want to do something by user enter keys, then you can play like that. This is not something. This is simple, unrealistic. Right? No rationale. There's no rationale, but I simply try to see some of the finger stroke, key stroke. If you extend this in the context of good rationale, medical rationale, then some of the rehabilitations treatment, so that you can train patient to press the keys, left key, right keys, under some rationale, and therefore you can train the patient continually, and you can gather some of the behavior like this, and do some further analysis. Okay, so exceptions may occur in any situation. Definitely, exception occurs if you do not care any situations seamlessly, full careness. So one of the full care treatment, careful treatment is to include exception handlings in your codings, so that you can touch with no loose points. That is the weak points of your systems. That is the point of cyber security attacks. Okay. Any question? Any comments? Finally, we will have one homework assignments. Okay. So example is this: enter your membership super. Then warning: your membership is not in. Your membership is in the blacklist. So what we mean by that is here, memberships only gold and silver. This is a dictionary. If it's gold and silver, then the value to this key, gold and silver, there is a number one. Number one means true. If membership called brilliant or super, then that is false. Another dictionary here, given transfer. This is banking systems. Somebody wants to transfer the money lower than 500, or lower than 500, or more than 2,000. No, I would say you can request, for example, Zelle transfer. Then you can transfer minimum 500 or maximum 2,000. If anyone in between, we do not know. What that means is 2,000 and 2,000, between 2,000 and 10,000, we do not know. But we definitely know if it is over $10,000, then disapprove. Deposit, if it is over $10,000, deposit is reported to IRS. You know all, right? So that type of things, somehow some rules, okay, in the banking systems. So we have a function called the nested exception for bankings. Takes membership, transfer, and deposit. And we try to take membership from user. And that membership applied to membership dictionaries. First of all, it's not necessarily gold, silver, brilliant, super, and something else. Then definitely there is an error, right? You need to handle it. If it is brilliant and super, then you immediately, if you can get some, then there's a good membership. Other than that, bad membership may be in blacklist, right? So you have to print that. Once it's good membership, then you have another here. While good memberships, you have to ask user to do it like this. Enter type silver. Then you need to ask, what do you want? Are you going to want to transfer, deposit, or quit? So I said, transfer. How much do you want to transfer? So $20. There's insufficient amount. Insufficient amount is chosen. How much do you want to transfer? We keep asking, right? Until we make a proper services. 50,000, too big amount to transfer. How much do you want to transfer? 7,000. Undecided for money transfer. In this case, it's not decided, right? As I said here, in between this 2,000 and 10,000. So how much we do? So different messages, right? How much you do? 1,500. Transfer successful. What do you want to do? We're still doing services, right? Transfer, deposit, and quit. This guy wants to deposit. And how much do you want to deposit? 15,000. Deposit amount over $10,000 should be reported to IRS. How much do you want to deposit? This is some number. Successfully deposited. What do you want? Quit. So this kind of while loops, there's a nested while loops, and also exception handles in different levels, outer exception handles and inner exception handles. A little bit of complicated, but I want you to handle this scenario, and this is another simple scenarios, right? From your desk. That is the homework.